All right, here we go. Unit 1, Lesson 3. This is our first lesson. I apologize, the last lesson went long. I'm trying to break them up into smaller videos. So we may break this one up into 2 videos as well. So again, talking about domain and range, we've kind of touched on this. But again, your range is like your y values and your domain are your x values. So if I'm looking at this this graph right here, okay, and I wanted to kind of identify my domain, I would say that I can see, hey, my graph starts at -1 and then it goes all the way to 4. So I might say that my domain is -1 to +4. Now, notice I used brackets. And the reason I used brackets is because we have a closed circle. So, Mr. Larson, you should not have used a bracket here because that's an open circle. Open circles mean that it is not included, it's excluded. So our domain includes -1, but it does not include 4. So any number in between -1 and 4 would apply to our domain, but 4 would not because of this open circle. Now our range, again, range is like our y's. So my range, again, I have a closed circle, and that's at -5. Because remember, it goes x comma y. So my range, my lowest value I can have is a -5. And my highest value I can have is a 4. And that is a closed circle. So I need to use brackets again because this is a closed circle. It can be anywhere, including -5, all the way up to +4. Now, a couple other ways we may have to find domain and range is by looking at a function. So let's say that we have f of x equals the square root of x subtract 4. Now we know, okay, we've talked about this. You cannot take the square root of a negative number, okay? Negative, it can't happen. Nope. Okay, so all of these numbers, whatever is inside my square root sign, it's gotta equal something greater than or equal to 0. So if I think about this, I'm gonna take what's underneath my square root, kind of like symbol or house. If you wanna think about this top part as like the roof of the house, everything that's underneath that roof, I need to have it equal greater than or equal to 0. It's okay to take the square root of 0. The square root of 0 is 0. However, it cannot go negative. So if we just solve this, again, we treat inequalities just like an equal sign. There's one special rule. Does anyone remember what that one special rule is with an equal sign? So we don't have to do it in this case. We'll talk about it in a second. So my domain in this case would be any number greater than 4 or equal to 4. So I would say, I like interval notation. So I would say, yes, because of this, it can equal 4. And we talked about you can never equal infinity. So any number greater than or equal to 4. Now, like we were kind of saying, the one special rule is that if you said say it was -2x greater than or equal to 0, if you divide by a negative number, you have to flip your equal sign, okay? Now that's a bad example because anything divided by 0, maybe it's 1, okay? So if I divide by a negative number, I have to flip my sign. That's the one special rule with inequalities. And again, kind of very similar, our range, just because it's a square root, and I'll show you a picture of the graph in a second, the square root is never going to go below 0. So any number that's not negative. So 0 all the way to infinity is going to be my range for this function. So algebraically, we can find the domain and range, but we can also use our calculators. So I've typed in my function in the top here, square root of x subtract 4, and we can see, hey, it doesn't go all across my graph, right? It is starting, and if I want to figure it out, I can click on it. Let's see. Oh, there we go. I know that, hey, my x is 4, so my domain starts at 4, and my y is 0, so it starts at 0. And you can see it's continuing to climb and climb and climb, and it's going to keep getting bigger forever. Not by a lot, right? We're at x is 600, and we're barely above 25. But it will continue to climb and climb and climb forever, even if it's a little tiny amount each time. Okay, so again, you can use your calculator as well to figure out kind of domain and range along with our knowledge of graphs. And then we also kind of talk about the vertical line test. So I know we've touched on this. Again, it's maybe review for some of us, but let's say that we have, I'm just going to draw one up here. Let's say that we have our window, and it looks something like this. So that's my x and y axis, and I have a graph that looks like this. Okay. If I look at, let's just pick 2 points in general. If I look at, let's call this 1, and then let's call this 2. At x is 2, my graph touches x equals 2 in 2 different places. So this fails the vertical line test. Okay, so you can plug in equations into your calculator, and if you see kind of this is a parabola, but it's flipped onto its side. If you see a parabola that's flipped onto its side like this, and it fails the vertical line test, it is not a function. It does not work. However, again, maybe let's draw a different example. You might see a graph that looks something like this. It can have multiple peaks and multiple valleys. We call those maximums and minimums, and we're going to get into that in our second video of lesson 2 or lesson 3. This one, again, if I were to just look at any random point, it doesn't matter what point it is, only touches my graph once. Only touches my graph once. Okay? Only touches my graph once. So I know that this passes the vertical line test. I'm just going to say vertical line test VLT. Vertical line test. So it is a function. This one is a function. All right, we're going to stop there for this lesson just to keep